So what I'm going to show you today is how they figured out that Dalton's model was not complete. And it began with this thing called a Crooke's tube. Has anyone seen a Crooke's tube before? This is a Crooke's tube. What it is it's a tube of glass that's mostly evacuated, meaning most of the air is taken out of it. And it's got an electrode on this side and an electrode on that side. If you look on the inside of it, there's a white screen, and the white screen is there for reasons I'll show you in a moment. This is a Tesla coil. Tesla coils generate lots of voltage. Right now there's a magnet inside of here that's spinning, and it's got some wires around that magnet. So it's generating a lot of voltage as it spins because it's a strong magnet. In fact, if I hold another magnet up here, I can feel it vibrating from the spinning of the magnet. Kind of like your rumblers on your game controllers. And but this is generating a lot of electricity. You can see that if you hold it up to something metal. People always ask what will happen if you touch it, and the answer is you'll die. That's why I am now dead. A little bit uncomfortable. But in any case, here's what happens when you hold it across a Crooke's tube. Everybody see that? You see it over there on that side? Everybody see it? Pretty cool. I actually can't see it from my side, but I assume you're seeing a straight green line. Mostly.
Why can't you see it?
Because I'm looking from behind. That white screen's only on the front. It's set up to be viewed from one side only. Alright, now, this is kind of interesting. Watch this. Is anything happening?
Yeah.
What's happening? It's following the magnet, reacting to the magnet, it's deflecting the magnet. Okay? So, that's kind of interesting. Keep that going. I got a one other thing to compare that to. I have a light here, and I'm going to pass this light. It's a laser light. It's a green laser light. Don't fail me. Oh, there we go. See that? So you see that? See that laser light? You see it there? Mm-hmm. What will happen to it when I get it close to the magnet? Deflect away. He says. Is it deflecting away?
No.
It has no effect on the magnet. The magnet has no effect on it. So why does some light get deflected by a magnet and some other light doesn't? Why is that? What's the primary difference? Why? The answer is, does anybody know what is different about that light from this light? Why are they different? What's one have that the other doesn't?
High voltage.
Yes. The specific word we're looking for here.
One's charged by electricity while another one's charged by battery.
Oh, batteries are electricity. But you kind of got the right word there. charge is the key. It turns out that this light isn't charged at all, it's just light. This is obviously, it's charged because that's what magnets do, is they deflect charges. They'll either make things go towards them or away from them, depending on if it's plus or minus or the north or south pole of the magnet. And so what we have discovered here is that there's something going through here that is charged. Something's jumping out of this metal electrode into this metal electrode that is charged. And since these metal electrodes are made of atoms, then atoms must have something charged in them. And J.J. Thomson is a scientist on our paper that we researched. This is what he discovered. He discovered that these things, the atoms, had these charges inside them called electrons. Those are actually electrons going across there. And J.J. Thomson discovered them.